next disk scheduling is SSTF, right, or the shortest seek time first. Okay, so SSTF scheduling is more efficient, but may lead to starvation if constant stream of requests arrives for the same general area of the disk. So SSTF reduces the total head movement, right, to 236 here. So that's down from 640, require the same set of requests under first come, first serve. Okay, so we get 640 from the previous disk scheduling algorithm, and we are expecting this SSTF be equal to 236 cylinders. Note, however, that the distance could be reduced still further to 208 by starting with 37 and then 14 first before processing the rest of the requests. So that is on the next algorithm. Okay? Alright, so with the shortest seek time first, okay, so again, our current position or the head starts is at 53. Okay, so from the algorithm, we have to select the request with the minimum seek time from the current position. So if we are going to evaluate this, from the current position, the value on the right is 65 and the value on the left is 37. So we have to get the distance, right? So between 37 and 53 and 53 and 65. Okay? So from 53 to 37, okay? So the distance would be 16. And from 53 to 65, the distance would be 12. So that means we have to select the request with the minimum seek time from the current position, that is to 65. Right? So again, from 53 to 37, that would yield to 16. And from 53 to 65, that would yield only to 12. Alright, so the current position is at 65 now. So 65 to 67 with 2, or 65 to 37 with 28. So of course, shortest seek time or seek distance, that would be 267. Alright, now current position now is at 67. So again, compare the distance from 67 to 37 or from 67 to 98. So 67 to 37 would give you 30, and from 67 to 98, that would give you 31. Right, so that means we have to go to 37. Right, so again, the current position is at 37, so you compare 37 to 14 or 37 to 98. So 37 to 14 would yield to 23, and 37 to 98 would yield to 61. So of course, shortest seek time or shorter distance, so we go to 14. Alright, and then from 14, okay, so the next thing is to go to 98 because that is the next request on the queue. Alright, so you've got 98 there, and then going to 122, 124, and you also have 183 on the request queue. Alright, so now that we're done with the SSTF graph, so now we have to get the table. Now again, your table comprises of 2 columns here. So the next track accessed, this is based on the graph here, and the next track traversed, that is the distance from one point to the next point. Alright, so from the current position, which is at 53, so next dot is 65. Alright, and 65 minus 53 would yield to 12. Right, next current position 65, next is 67. So 67 to 65 would yield to 2, and then from 67 next here is 37. Right, and the distance is 30. Right, so from 37 next on the table is 14. Okay, so would yield to 23. 37 minus 14 is 23 there. Right, so next would be from 14, that would go to 98, So 14 to 98. So if you're taking the difference, then you have to take the absolute value, and that would give you 84 there. Okay, so from 98, next would be 122, right? So the difference, 98 to 122, that's 24. And then from 122 there, next is 124 on the Q. Okay, so that is 2. And from 124 to 183, so that is 59. All right, so next would be, you get the total of this next track traversed, and that would give us 236 cylinders. So with the average of 29.5. All right, so that's a shortest seek time first. Okay, so let's move on to the next algorithm.